Hello everyone, welcome to my session about Managed DevOps Pools. The plan for today is that I give you a quick introduction about some security features we have in Azure. Then I'm going to give you an introduction about the different options we have for self-hosted Azure DevOps agents, and then we spend most of the time for Managed DevOps Pools. If you're interested in the slides or the code of the demo, you can scan the QR code and you will find everything I'm showing you today. Before I get started, a couple sentences about myself. My name is Wolfgang Hofner. I'm a freelance cloud architect. I'm based in Toronto, Canada, and I focus mostly on Azure, especially on governance and security lately, but also on Kubernetes and DevOps. If you're interested in these topics, you'll find a lot of videos on my YouTube channel, and if you have any questions after the session, feel free to message me on LinkedIn. So now let's get started with some very basic Azure security. So the first challenge we are facing is that we often have passwords and secrets. For example, in the past, when our web application wanted to access a database, we had a database user and a password, and we had to provide this information to the web app. It works, but it's a pain because we have to make sure that the secrets are stored somewhere securely. We have to provide them to the web app, and we also don't really have a monitoring option to know who is using the secrets or the passwords and who knows about them. Then the second thing I want to talk about is the way Azure works. So by default, most of the services are available over the internet by default. That's great because we can just create a new service, for example, a database or a key vault, and then we can easily access it. The problem is that everyone else could also try to access it. So from a security perspective, it would be way better if it is only available over a private connection. And to solve these two problems, we have different options in Azure. So the first one is Managed Identities. With Managed Identities, we can give permissions to these identities and then assign the identities to our services. For example, I can give the database reader permission to my managed identity and assign this identity to my web application. Therefore, my web application can access the database. I don't have to deal with any passwords or secrets, and it's also secure so nobody can steal it because the managed identity is only linked to my web app. Then another option I have to increase the security is to remove the public access from my services. This means I can't access them over the internet and I can only access them over a private connection. This means from within the VNET. The way it works is I create a private endpoint for my service. For example, for my key vault, I can create a private endpoint, and with this private endpoint, the key vault will be attached to my VNET. So this is basically adding a network card to my key vault and attach it to my VNET. Therefore, the key vault gets a private IP address from my VNET, and I can only access it from within the VNET. So this is something we're going to take a look at today in the demo. So we're going to use Managed Identities to access the key vault, and we also have the key vault only available over a private connection. Therefore, we won't be able to access it over the internet. So here we can see an overview of a very simple architecture, how this could look like. So here we have different Azure VMs, and they can all connect to the SQL database over the private endpoint. We can see the IP address is 10.0.0.5, a private IP address, and the VMs can access it. What's important is it's not only within the VNET, I can implement VNET peering. This means I can connect multiple VNETs together, and then resources in other VNETs can also access my database. We see also here on the image that I can have a VPN gateway. This means other VNETs or on-premise services can also connect via this VPN gateway to my VNET and therefore access the database over a private connection. What's important here is we can see we can't access the database over the internet. This means we can keep it secure, but we also face some challenges. For example, how can we do the deployment to a private resource? And this will be the main part of the demo later. But before that, let's talk quickly about what a private endpoint is and how we can use it. So I said before, a private endpoint is basically a network card that will be attached to our service and then to the VNet. This means my database, in the example of the screenshot before, gets the private IP address from my VNet. Then what's important is when I create a private endpoint, I can also create a private DNS zone. And this is great because the private DNS zone overrides public DNS entries, and therefore I don't have to change my services. For example, my web app can still access my database over the DNS entry, except this time it's using the private DNS zone, and therefore it's routed to the private endpoint and therefore to the private IP address. Once I have enabled this, I can block the public access and therefore can keep my database or any other service, like today we're going to see a Key Vault, secure. One challenge we are facing when we have private endpoints is how can we do the deployment? If you're using Azure DevOps and a Microsoft hosted agent or GitHub or any other tool, then the public agents can't connect to the private endpoint because they are hosted somewhere on the internet. And as we just disabled the public access over the internet, the connection won't work. So if you take a look at the architecture again, so everything you can see here in the green squares, the Azure VMs can connect to our private endpoint, therefore to the database. But our Azure DevOps agent, for example, is living on the internet. So it would connect over the internet, and this is not possible. So the solution for this kind of problem is to have a self-hosted agent. This means we have an agent that is running within our VNet or in a peered VNet, and therefore the agent can connect over the private IP address to our service. Before we do this, I also want to mention the difference between the management plane and the data plane, because this leads to quite some confusion. That's the way how Azure is architected behind the scenes. So I have the management plane. This is how I can create resources. For example, create a Key Vault, create a VM. This is done with the management plane. So behind the scenes, we have ARM, the Azure Resource Manager, and it's just an API call, and I can create these resources. This is not affected if the database is public or private. What is affected by this is the data plane. This means if I want to connect to the database or if I want to access a secret inside the Key Vault, this connection is made private, and therefore my deployment agent is not able to access or create secrets or read data from the database. So now let's take a look at self-hosted agents for Azure DevOps. The reason why we want to do this is we have the full control over the infrastructure and the software. So as I said before, we can place our agent inside this VNet, and therefore the agent can deploy to our private resources. Additionally, we can install whatever software we want. The Microsoft hosted agent comes with pre-installed software of the most common tools. For example, we have Docker, we have .NET. But if you have something a bit more exotic, or maybe you need an older .NET version that's not available anymore, then you can install it on your own agent, and it will work for as long as you update it. This also allows you to use highly specialized agents. So for example, I can have agents that are tailored to my software, and they only have the software I need to build my packages or whatever I want to use. And with this in combination, I can have very powerful hardware. In Azure DevOps, the Microsoft hosted agent, they have, I think, 2 CPU cores and 7 GB of RAM. So that's quite limited for bigger builds. But if I host the agent myself on maybe a VM, I can use whatever size I want. So I can have 30 or 60 CPU cores, half a terabyte of memory. As long as I pay for it, I can use whatever I want. And this already leads to the disadvantages. So I have to pay for the infrastructure. So if I use a really big VM, I have to pay for the VM. And I also have to pay for my team who's operating these VMs. This means I have to have some monitoring in place. So if my VM doesn't work anymore, I want to be notified. I also have to update the operating system. I have to update the software. For example, in November, we will get .NET 11. This means someone from my team has to connect to the VM and install .NET 11. Otherwise, I don't have it available. So now let's look at the options we have to run our self-hosted agents. So the default for many years was to have a virtual machine, or in Azure we can have a virtual machine scale set. So that's a copy of the same VM if you want to scale out. It's easy, everyone knows how a VM works. The problem is VMs are really expensive and I have a lot of overhead. This means I have to update the OS, I have to update software, I have to take care everything works, and often I have the VMs running and not being used. Therefore, a lot of expenses for not much gain. Then a bit more modern approach would be to run our agent in a container. This is great if you already have a Kubernetes cluster. You can just start one more application and have your agents running there. We also have container apps in Azure, which would be an option. The problem is that Docker in Docker is not that simple because you have problems with the permissions, and there are a couple tools that supported this, but some retired. So there's not a straightforward path to have your agent running in a container. But fortunately, for around 1.5 years, we have now managed DevOps Pools. And this is, in my opinion, one of the best services we have, and it solves almost all the problems we have with self-hosted agents. So now let's take a look at the managed DevOps Pools, and then we go over to a demo where I show you how to implement it. So my opinion is that the managed DevOps Pools provide the best of both worlds of Microsoft hosted agents and of self-hosted agents. This means we can combine almost all the advantages without almost none of the disadvantages. The way it works is that Microsoft or Azure manages the VM where your agent is running on. This means you don't have to create the VM, you don't have to install any updates. You just select what size you want, and Microsoft installs the agent on the VM on the fly for you. This also allows you to only pay for the agent or the VM while it's running. This means if I run my pipeline for an hour a day, then I pay only for this 1 hour. I don't pay for the 23 hours I'm not using this VM. One advantage of this is that I can use really powerful VMs. Since I only pay for the time I run my pipeline, I can use the most powerful VMs. I only pay a couple cents or maybe $1 while I run the pipeline. Additionally, we have some great features for managed DevOps pools. The first one is that we can assign a managed identity to our managed DevOps pool, and therefore the DevOps pool or the agent can easily access other services. Today I'm going to show you how we can give the managed identity permissions on the Key Vault, and therefore my agent is able to access my Key Vault without the need of a username or password. Additionally, I'm going to show you how we can integrate this managed DevOps pool with our VNET. Therefore, the agent can also access the Key Vault or any other service over a private connection, and we don't have it to be available over the internet. Then before I said, we have the Microsoft hosted agent, but we can also have our own custom image. This means we provide one image where we install whatever software we want, and then Microsoft takes this image and installs the agent on top of this image. So again, I don't have to manage anything with the agent. Everything will be done by Azure. The one downside with this approach is it takes a couple minutes until the VM starts. So if I have a pipeline and I start the pipeline, then I have to wait on average between 3 and 5 minutes in my experience. So to go around this, we can also have standby agents. This means the VM is already running, and once the pipeline starts, the VM will just pick it up. The downside is I have to pay for this, but I can also have it with some logic behind. For example, only have a standby agent from 9 to 5 when my teams are working. And I'm also going to show you later in the demo how we can reuse the VMs. So I only have to wait the first time I started, and then for all the following pipelines and jobs, I'm going to reuse the same agent and don't have to wait. Then another limitation, which is not very DevOps pool specific, but Azure DevOps specific, is that the amount of parallel jobs is limited by the licenses you have for Azure DevOps. But this applies to no matter what kind of agent you're using, but I still want to manage it. So if I have 2 licenses and I say I want to have up to 5 agents running at the same time, I can still only have 2 parallel jobs at a time. So now with all this demo done, with all this theory done, let's take a look at the demo. So I'm going to show you how to set up everything from zero. So if you want to follow along, you can scan the QR code from the beginning of this video, or you will also see it at the end, where I have a script to set up everything. So first we're going to create a new Azure Key Vault with a private endpoint. And we want to have the deployments only from within the VNET. This means we have to disable the public access, we have the private endpoint, and we have the permissions. To do the deployment, we're also going to create a managed DevOps pool, which will be integrated into this VNET. And after we have everything set up, we're going to test the Key Vault access with an Azure DevOps pipeline. So now let's switch over to the terminal and let's get started with the demo. All right, here in the terminal, let's define a couple variables first. So these variables are just some basic information like the name of the resource group, the name of the VNET, and also, for example, here the ID of the subscription. I selected the location Canada Central because that's the closest to where I am. So you can change this to something, for example, West Europe, if you're in Europe, and you get some better latency. Then we're going to define the variables for our managed DevOps pool. So that's just a pool name, the Dev Center and the Dev Center project. I'm going to tell you later all the details about this. And then lastly, we have the information about our Key Vault. So the Key Vault name, the name for the private endpoint, and the name for the DNS zone. What's important is if you follow this demo that the name of the Key Vault has to be unique worldwide. So you would have to change the name. But I also provided the comment here to remind you. So next we have to install 2 extensions for the Azure CLI. The first one is named Dev Center. So here we'll see I already have this extension installed and I also don't have any updates available. And the second one is called MDP for Managed DevOps Pool. Here also I have the newest version, and with this we're ready to go. So first I'm going to create a new resource group and we're going to deploy everything inside this resource group. Then after this I'm going to create my VNET. So here you can see we have the information from before, like resource group name, VNET name, the location, and subnet name. For the subnet and the address, you can use whatever you want. I'm just going to use 10.0.0.0/16, and the subnet is going to be /24. After this, I'm going to create a new subnet, because our managed DevOps pool has to be in a specific subnet. So let me paste the command and then we take a look at it. So here I'm using the AC network VNET subnet create. I again provide all the variables, and here I use a different prefix. So I'm using the 10.0.200, so it's very easily to see that this is different. And what's important is if you're using managed DevOps pool with a VNET integration, we have to provide this delegation. This means we tell Azure that this subnet is only for services of the type Microsoft.DevOpsInfrastructure/pools, which is the managed DevOps pool. I'm also going to query the subnet ID because I'm going to need this in the next step to provide some permissions. So this should only take a couple seconds. And there we already have it. Now if you take a look at our subnet ID, we can see we got the ID. So now we have to also set the permission of a service principal for this subnet. So first I'm going to get the ID of the service principal. And the service principal is called DevOps infrastructure. So that's a service principal that's created by Azure. So it should already exist in your tenant. And I'm just getting the ID of this service principal. And then with this ID, I can do a role assignment. So here we have the role assignment of the ID we just queried. I provide the role reader, and we can see here under the scope that I give the permission on my entire VNet. This means the service principal can read the VNet. That's just one of the requirements for having a managed DevOps pool inside a VNet. This should only take a couple seconds, and then we're going to create a second role assignment. So this is again this DevOps infrastructure service principal, but this time we provide the network contributor role. So again, this is just necessary for managed DevOps pool to be able to get injected into a VNet. Next up, we're going to create our key vault. So again, on the top, we provide the same information as before. Then I enable the RBAC authorization. This means we're using Azure RBAC, so I can provide roles to my identities to access the key vault. I'm already disabling the public network access. This means nobody can connect over the internet. And this bypass none is a setting that you can have Azure services bypass the firewall. I'm going to show you this in the Azure portal later again. And this is something, in my opinion, should always be disabled. And it's one of the worst settings because every Azure IP, no matter if it's in your tenant or any other tenant, can bypass the firewall. Therefore, basically opening it up to almost the entire internet. All right, so now you have our key vault. Next, we want to create a managed identity and then assign this managed identity permission to access the key vault, and then in the end assign it to our managed DevOps pool. To do this, I do just a simple AC identity create, again with the same basic information from the variables, but I also query the principal ID. And I need this ID to assign the permission in the next step. After creating the managed identity, you might have to wait for a couple seconds, up to 1 minute, because the propagation in Azure sometimes takes a couple seconds. So if you don't wait and execute the next command instantly, you might get an error message that the identity doesn't exist yet. Now that we waited a couple seconds, I can paste the next command. That's another AC role assignment. I assign the role Key Vault Secrets Officer. This means my managed identity can do everything inside the key vault with secrets. I provide the ID of my managed identity, and as the scope, I provide the key vault. So now we have the key vault, and we have the managed identity that has the permissions to access the key vault. Next, we have to create the private endpoint, so we can connect over the private connection to the key vault. This contains of a couple steps. So it's very easy in the Azure portal. If you do it the first time, you may want to do it there. But when we script it, we have to do a couple steps. And the first step is to create a private DNS zone. So this should only take a couple seconds. And this private DNS zone will then later be linked to our VNet. And therefore everything inside the VNet knows how to access our private endpoint and therefore the key vault. Creating the private DNS zone usually takes around half a minute to a minute. So as we can see, we have it already finished. Next, we create a link from the private DNS zone to our VNet. So we provide all the information, like again, resource group, the VNet name, the DNS zone name, and the name of the link, I think is this parameter. And I also like to enable the registration, because this automatically adds the DNS to resource inside this VNet. This should only take a couple seconds. And after this is done, we can now create our private endpoint. So here we say we have this new private endpoint inside our VNet, inside the default subnet. So that's not the managed DevOps pool subnet. Then we provide just a name. The private connection resource ID. It sounds very complicated, but this is basically just a link to the key vault. So this is the entire ID of our key vault. Then we have to again tell it that it's using a key vault. Therefore we have the vault. And then we just have any name, and this will be used for the link of the private endpoint to the VNet. This takes only a couple seconds. And after this, we have to take one last step, and this is adding the private endpoint to the private DNS zone. So to be specific, it's a private endpoint DNS zone group we are going to create. So we provide the name of the private endpoint, the name of our DNS, and then just the name of the zone. By default, if you have a key vault, it's always private link Vault Core Azure Net. So you don't have to change anything here. This should also not take too long. And then we have everything set up from our environment that we can get started with the managed DevOps pool. So here we have now the link set up. We can also see here already, we got the private IP address. So that is the 10.0.0.4. We also have here a record type. This means an A record, and it's succeeded. So everything looks great. Now we can get started with the managed DevOps pool. Usually I would always recommend to set it up with the CLI or any other tools like Terraform or Bicep. But I think for the first time it's easier to understand what's happening is in the Azure portal. So therefore we're going to switch over to the Azure portal in 1 minute. I only want to deploy first one dev center. So this is something we need behind the scenes, and the dev center is taking care of creating the VMs, but we will never interact with it. So we just have to have one. Then we tell our managed DevOps pools that here's the dev center, and that's it. So we don't have to know any details about it. All we have to know is it has a name. And once this dev center is created, we also have to create a project inside this dev center. But again, we don't interact with it at all if we use Managed DevOps Pool. It's just something that needs to be there for the behind the scenes work. This usually takes a couple minutes, so I'm going to stop the video now until the dev center has been created. It took a couple minutes, but the dev center is created. Now we create a project inside this dev center. So what we need is a name for the dev center, and most importantly, the ID of the dev center where we want to link it to. Then we have some basic information like the description, but as I said before, that's not very important. So we're going to create this dev center project now, and once it's created, we can move over to the Azure portal. Then we're going to take a look at what we created, and then we're going to create our managed DevOps pool. It took only a couple seconds, but now the dev center is created. If you follow the demo, I also have the code there to create the managed DevOps pool with the Azure CLI. So this is just one more command you have to execute. But as I said before, I think it's easy to understand for the first time if you use the Azure portal. So now let's switch over to the Azure portal and take a look at what we have created so far. All right, here in the Azure portal, inside the resource group we created, we can see all the resources we have deployed. So for example, we have here our key vault. Then if I click on the secrets or anything else, it tells me the public network access has been disabled and therefore I can't access the secrets. If we take a look at the networking, we can also see here the public access has been disabled. And down here we have the one setting I said before is the worst setting we have. And it sounds great because allow trusted Microsoft services to bypass this firewall sounds like other Microsoft services you have. But again, This is any public IP from Microsoft or from Azure. This means somebody else in a different tenant can create a VM, and then this VM could access your key vault if they have the permissions. What you can also see here is under private endpoint is the private endpoint we created. We have some information like the name and the VNET and subnet. If we click on this private endpoint, we have again all this information as well as the DNS configuration. So down here we have our IP address, the one we've seen before, the 10.0.0.4. And we also have here the link to our private DNS zone. So we can also click on this, and then we click on the record sets, and we can see here the record has been created automatically. So we didn't have to do anything besides executing the script. And now with this A record, our managed DevOps pool will be able to access the key vault based on the DNS entry. So let's close this, and now let's take a look at what else we have. So we have here our managed identity. So far we haven't done anything with this identity except we gave it a role assignment. Here we can see it has access to the key vault, and it has the key vault secrets officer. This means it can read and write secrets in the key vault. Lastly, we have also our VNET there. So if you open this and click on subnets, we can see we have the two subnets, and the second subnet is delegated here to the Microsoft DevOps infrastructure /pools. So that's the one we're going to use for our managed DevOps pool. Speaking of managed DevOps pool, now let's create the first pool. So you can search on the top for managed DevOps. There you can see I don't have any yet, so we click on create. And here we provide some basic information like the subscription management group. Then here we can also see we already have the dev center and the project. In theory, you can create a new one here, but if you don't have any yet, then the UI doesn't work. It just will load forever and doesn't do anything. So you might have to create one before, and then you can select it here. Next, we provide the URL of our Azure DevOps organization. So I'm just copy and paste mine in here. Mine is programming with Wolfgang. Then we provide a pool name. So that's the pool we're going to reference in our pipelines. So I've already prepared one. So I call it MDP Identity Demo. Then we have the region where we want to deploy it, the amount of maximum agents. This means how many parallel jobs do you want to have. So for now, I just want one. Then we can change the size of our VM. So by default, we have 2 cores and 8 GB of RAM. So if you click on change size, if you have a new subscription, you only have a couple SKUs available. Like you can see here, I have 46 available and over 900 not available. But you can just create a ticket with Microsoft usually and request more quota. And then depending on the location where you are, you might get it or might not. But what you can see here is I can select whatever VM I want. For example, if I want 4 cores and 16 GB of RAM, or even 28, I can just select it. And if you take a look at the unavailable ones, so these are the big ones. So the L and M series are usually the bigger ones. And if you take a look here, with 80 cores, half a terabyte of memory, and they're even way bigger. Like here we have a couple terabyte of memory, hundreds of CPU cores. So you can use whatever powerful VM you want. This might make sense for your workload. For example, I have a team that's creating their own Linux distribution, and with the Microsoft hosted agent, it took over 1 hour to run the pipeline to create the image. With one of the more powerful VMs, I think with 32 cores, a couple 100 GB of RAM, it took around 5 minutes. And they only have to pay for the 5 minutes, so it's just a couple cents they had to pay on the VM. So it was a really great efficiency improvement with barely any cost. But for now, I just leave it with the 2 cores, 8 GB of RAM. That's plenty for me. Then the OS disk, I always like to use at least standard SSD. but you could also use Premium, which is just a little bit more expensive. And lastly, we have to select the image, which one we want. So by default, Microsoft selects just Ubuntu, which I don't fully understand because we don't have much software installed. For example, if I want to build .NET, I don't have .NET there by default. So I'm going to delete this one and select a new image. So here we have the Microsoft hosted agents. So that's the same as you would use with just Azure DevOps Microsoft hosted agent. For example, I have here the Ubuntu 24.04, which we're going to use. But I can also select one from the marketplace, like any Windows or Linux. And I can also provide here my custom images. Since I don't have any, I don't see them, but here they would appear. So now let's just select the Azure pipelines for Ubuntu 24.04. Add this one. And that's already the basic configuration. So if I just create my managed DevOps pool with this, I will get one agent or one VM that will run Ubuntu 24.04. We'll have the Microsoft hosted agent installed, and we'll have 2 CPU cores and 8 GB of RAM. But now let's take a look at all the options we have to add more configuration. The first one would be that every time you start a new job inside a DevOps pipeline, a new agent will be created. And as I said before, creating the agent takes on average between 3 to 5 minutes. So if you have multiple jobs, you wait quite some time. So what I like to do is I reuse my agent. And down here you can have a grace period. This means how long does this agent live without any usage. This means it's just idling until it's deleted. And you only pay for the time it's alive. So I like to have here 5 minutes. This means when I start a pipeline for the first time, I have to wait for the agent to be created. But if I run multiple pipelines or jobs after each other, it's reusing the same agent and I don't have to wait. Once I'm done, the agent will wait 5 minutes. This means idling around. And if no new pipeline is started, it will be deleted. So I only pay for this additional 5 minutes. Here you have to figure out what works best for you. This is the cheapest or almost cheapest version I could find of, and it worked so far. Additionally, you could also have standby agents. This means you always have an agent that's already ready to go, but then you also have to pay for it. So here under manual, you could select, for example, during my working times, 9 to 5, I want to have one, or I can also let Microsoft decide. So they will analyze your usage pattern and then will create the agent when they think you will need it. To save costs, I like to have this off usually, and I just wait for the agent to be created first time and then I reuse it. Next up, we want to add our agent to the VNET, so the agent can access the key vault over the prior connection. And we can do this by injecting it in a VNET. If we click here, we can see we only have one VNET and we see our 2 subnets. Unfortunately, the UI is not smart enough to know that which one is delegated to the managed DevOps pool, so we have to know it. If we select the wrong one, we'll get a validation error at the end, but we already know that's the MDP demo subnet, so I'm going to select this one. What's important is if you create this the first time or try out managed DevOps pool the first time, you can't create the VNET here. So you have to create it before and then you can select it from the list. On the next tab, here we could add additional data disks if you need more storage than the VM would provide. But we don't need this, so you can just skip it for now. Here in the security tab, you can configure how your agent will be injected into the DevOps organization. So on the first tab, we had to select one DevOps organization, but you could also add multiple, which I've never done because I like to have them separated from each other. So one managed DevOps pool per organization, but it's up to you. You have the option. Down here, you can also configure if you want to have this managed DevOps pool available for all projects or for specific ones. To keep it simple, I just add it to all the projects. Then we have some other informations which we also have for other agents. For example, Does the pipeline need approval to use the agent the first time? Do you want to have the interactive mode if your workload needs this? And down here we have the pool administration. Here usually I go with inherit permission from project, because the Azure DevOps project already has the permissions in place, and the administrators there can also administrate my managed DevOps pool. Under advanced, we can just set the work folder of our DevOps pool, which I've never used before. Then we also don't need any tags. And now we can create our first managed DevOps pool. This should only take 1 or 2 minutes, so the deployment is really fast. And what's happening right now is it's creating a new agent pool in our Azure DevOps organization. It will add this agent pool to all the projects, and we'll also set up the integration of the managed DevOps pool. So I'm going to stop the video, and once this is done in a couple minutes, we will continue and take a look at what we have just created. The managed DevOps pool is created. Now let's take a look at what we can see here. So on the overview page, we just have some basic overview, like how much is the pool used, how long does it take to create a new agent, how long do the pipelines have to wait if there are any errors. So what we're used to have on Azure. Then on the side here under settings, we have all the settings we have seen before, except one is new, and that's the identity. Unfortunately, it's not possible to add the identity during the assignment in the Azure portal. If you follow my demo code and use the Azure CLI, you can just add the identity during the deployment there. But for now, we have to add our identity. Since I only have one, I can just select it from this overview here. Then we're adding it. And now our agent can use this managed identity to access other services. So far, we only have given it access to the key vault. This means it can only access the key vault. But in a real world project, it could also have access to a container registry or a database, whatever your project needs. So now we are ready to try it out and see if the deployment works. So let's switch over to Azure DevOps. Here I'm in my test project, and if you are in the agent pools, I just refresh this page. Now we can see we have here this new agent pool automatically created for us. It has the same name as our agent pool in Azure, and now we can reuse it. So I also have here a demo pipeline. I'm going to start this pipeline because it's the first time, so it takes around 5 minutes. And while the agent is being created, we can take a look at the pipeline itself. So what's important is the first time I start it, I also have to approve it, because I didn't check the setting during creating the managed DevOps pool. So I have to permit my pipeline to use the agent pool. So now it will take a couple minutes, but if you can refresh this again, it should say here, acquiring an agent from the cloud, and we're provisioning an agent for my request. This means right now Azure is creating a new VM, is installing the agent there, and then I will be able to use this agent. In the meantime, let's take a look at the pipeline. So the most important part of the pipeline is the pools you're using. So here on line number 3, our pool is the MDP identity demo. That's exactly the same name as our DevOps pool. Therefore, we're using the DevOps pool for the deployment. Then what's really great here is I can use AC login identity with the -- identity parameter. And this tells the Azure CLI to use the managed identity we have attached to the managed DevOps pool. This means I don't have to tell the pipeline a name of the identity, a username, password, nothing. I just say use the identity you have, and therefore the key vault, the DevOps pool will be able to access the key vault. So on line number 19 here, we can see we do an AC key vault secret set, which means we create a new secret inside the key vault. This will prove that we have access to the key vault over the prior connection. Since I don't have access to the key vault, I can just open it and show you that the secret is there. And therefore, I do in the next step secret show. This means I read the secret and then I write it into a text file. Fortunately, Azure DevOps is smart enough to know that it's a secret, and if I would just print it to the console, it would just mask it so I can't see it. But if I write it into a text file and then I publish this text file down here, I can download it and I will see what the secret says. So now let's go back to our execution. So we can see here, it's still waiting. So I'm going to stop the video now. It should only take 1 or 2 more minutes. And once the pipeline starts, I'm going to restart the video as well. So our agent has been created. It took around 2.5 minutes. And now the pipeline is executed as if you would use another agent on a VM or the Microsoft hosted agent. So the first step here, the creating the secret, takes around 40 seconds. This means that the Managed DevOps Pool or the agent logs into the Azure CLI using the identity we provided, and then using this identity to access the key vault and create the secret there. So this should only take a couple more seconds. So you can see we have now the login and we just created the secret. Now it's reading the same secret, it writes it in a text file, and then it publishes the artifact. So this is done now. So we can go to our pipeline run. We can see it was successful and we have here one published artifact. Then we can download this text file and open it. And here we can see it says this is a secret. This is exactly the secret we wrote into the secret. This proves we were able to access our key vault over the private connection, write the secret, and then also read it. So now if I want to run my pipeline again, I don't have to wait a couple minutes because my agent is still waiting for me. So I configured that my agent should wait 5 minutes. This means right now the agent is idle, and there you can see the agent was already around and almost immediately picked up the pipeline. Then the create secret task only took a couple seconds because the secret is already there. So it was basically skipped, and it read the secret again and published it again. So that's it. We can see we were able to access the key vault, and once we have the agent running, it takes only a couple seconds for the agent to pick up the pipeline. And this is everything I wanted to show you today. Maybe just one last thing is, if you delete the Managed DevOps pool, it will also automatically delete the agent pool in Azure DevOps. So here, if I delete my agent pool after this demo, it will also delete this agent pool. So I don't have to clean up anything inside Azure DevOps, which is also quite nice. So this is everything I want to show you today. In my opinion, Managed DevOps Pool is one of the greatest services we have on Azure and the best option to run self-hosted agents, which will allow us to deploy to our private resources and therefore keep them secure. If you're interested in the slides or the code I showed you today, you can scan the QR code and you will find everything on GitHub. Thank you for joining me, and I hope you find Managed DevOps Pools as useful as I am and you will use them in the future.